Hi everyone. Today we're going to be talking about circles as well as ellipses. But to get started, we're going to go ahead with 1.9, which is talking about circles, also using the distance formula as well as the midpoint formula. Both those formulas are going to be something you will need to have memorized for your exam. So, to get started, again, just as that basic definition for a circle is a set of all points P in a plane that are equidistant from a fixed point called the center. The fixed distance from the circle's center to any point on the circle is the radius. All right. A lot of this is some good background information that you guys may already have. To get started, we have the standard form of the equation of a circle. That's that formula right there, the x minus h squared plus y minus k squared equals r squared. Pay close attention. We have seen the letters h and k in the past, both in Algebra 1, Algebra 2, and in Trig previously this semester. Remember, those h and k's, when it comes to this formula specifically, they both have negatives in front of them. So we are going to have to remember that we are going to need the opposites when it comes to finding the h and k, because that negative is right there. So the h and k in our scenario for the circle, that is going to be called the center. Whatever the h value is, and the k value, of course, taking the opposites of what we see in the formula, that will be the center. And then the radius is going to be the r value. Again, you see r on the right-hand side. We're going to take the square root of whatever that r squared is, and we will get the radius out of it. And last but not least, just some key things to look at when it comes to the formula of the circle. Both coefficients in front of the x and y's are always going to be 1. And it will always be addition in between both. So coefficients always 1. And it's going to be addition. Key details. Definitely get those down. Make sure you pay close attention to the details of these formulas, as they will be very, very similar throughout this whole unit. So there's key details that change between each type of function. So I'm going to go ahead and give you guys an example. X squared plus y squared equals 9. This is an equation of a circle, first because coefficients are both 1s, and because we are adding both variables together. So that being said, that tells me that my center, I don't actually have parentheses with x and y, so my center is going to be at the origin, 0, 0, while my radius is going to be that 9 value, but of course my radius is always squared, so if I take the square root of that 9, that tells me my radius is going to be 3. So I'll start at the center. There's really no necessary need to put a point at the center because it's not graphing a point of a circle, it's graphing just the circle. But from the center at 0, 0, we're going to move to the right 3 units. Of course, that is my radius. It's telling me exactly how to shift. I'm also going to move up 3 units from the center, left 3 units from the center, and down 3 units from the center. And by doing so, I have just created my circle. All right, that is how we are going to graph the circle. So now looking down, we're going to go ahead and do a few examples. Question 1 says, write the standard form of the equation of the circle with the center at 0, 0, so they just told me my h and my k, and a radius of 2, which they just told me my r. So I'm going to use the standard form, plugging in a 0 for h and a 0 for k. And then when I plug in a 2 for my r, making sure I still square that according to the formula. If I go ahead and simplify this, it's going to give me x squared plus y squared, and it's going to equal 4. That is the official standard form of the equation. When I go to graph it, again, labeling my center, I don't need a point necessarily, but I just got to know where I'm starting from. And then my radius is going to be exactly 2 units to the right, 2 units up top, 2 units to the left, and 2 units down below, creating a circle. We'll keep going with a few examples here. If you want to try question 2, pause the video and try this one on your own. It is only asking you for standard form. No need to graph this one. Again, they gave us h, they gave us k, and they gave us the radius. Plugging that into my formula. Remember, it is always x minus your h value squared plus y minus your k value squared equals my r value also squared. And when I clean this up, you'll notice there are 2 negatives in with that x, so that is now going to change it into a x plus 2 squared plus y minus 3 squared equals 16. And that will be my standard form. Question number 3 says find the center and the radius of the circle whose equation is x minus 2 squared plus y plus 4 squared plus 9. So all I need here is the center as well as the radius. The center, remember, h and k are always opposite of what we see. So in this case, I see a negative 2 with x, but my h is going to come out as a positive 2. And I see a negative 4 with my y, so my k will turn out to be a negative 3. A negative 4. Followed by my radius, which is 3. The square root of 9. A lot of these we have seen before in these examples. Heading into question 4, we're going to start graphing these just to get some practice. Typically, in the future, I don't believe we graph circles very often, but in the event that we do, this is obviously going to be important. So remembering a few things, we're talking inequalities here. So first off, this first function is going to be a circle. It's also going to be graphed as a solid line, and it's going to be everything less than that. So if this is a circle, I'm going to go ahead and find my center, which is going to be at 0, 0, with a radius value of 2. I'll go ahead and make my picture. Radius of 2 and a solid line. Last but not least, I'm going to need to go ahead and graph this and shade it. And I'm going to need to shade everything less than. And in this event, it's going to be inside of the circle. So I'm just going to kind of throw some dashes through here so I still have enough space to make my other line. So the inside of my circle is shaded right now. I'm going to go ahead and solve the other equation, giving me y is greater than negative x plus 1. This is an equation of a line. I'm going to need a dashed line this time, and I'm going to want to shade everything greater than. So I put a point at 1. I'm going to use my slope down 1, right 1. Getting as many points as possible. It is not necessary to do every point. It just is going to make my graph that much straighter. Go ahead and go through with a dashed line. And I'm going to want everything greater, so it's going to be up here. And the key to point out here is when we go to shade, we want the overlapping section, which is going to be inside of this circle here. So that is the section that I would grade you on. That is the section that needs to be overlapping. All right, and what that means is that shaded area, anything that lives in that shaded area, any of those coordinates are going to work for not only one equation, but both. So we'll go ahead and try question 5 now. You'll notice both of these are circles, both inequality functions are circles. Starting with the center, it's going to be at -1, +1 with a radius of 4. So I'm going to start at -1, +1. That's shifting it just a little bit. And from there, in blue, I'm going to label all of my points from my radius. 4 up, 4 right, 4 down, and 4 left. And that will give me my circle. Remember, your radius is all in with respect to your center. So this is the first time we've seen a center other than 0, 0. So again, 4 units to the right from the center, 4 units from the top from the center, 4 units to the left from the center, 4 units down from the center. And actually, I'm going to need a dashed line for this. So I'll go through with my eraser, just give me some dashes since I forgot. All right. When I go to shade this one, since it's saying that both values need to be less than 16, that is actually going to be shaded on the outside. So again, I'm not going to do much. I'm just going to kind of make it look like a sun almost, because I still have, actually, I'm going to go back and do that one more time. The shading, can I make this bigger? No. Shading is actually not going to be on the outside. Shading is actually going to be on the inside. And the ways to check for that, again, is to test a point. We can test 0, 0, which tells me that 0 is for X, 0 is for Y. And when I plug that in, I get a 1 plus a 1. And is that less than 16? Yes. So that tells me I need to shade everything on the inside. Since 0, 0 lived on the inside, I need to graph and shade everything that's true, including 0, 0. Go ahead and do the same thing now on my second inequality. My center this time is at -1, 1. You'll notice it's the same center as before, but this time my radius is 2. So I'm going to go ahead and zoom in. The same center point, but now I'm only going to go 2 units right, up, down, and left with a solid line. And this time it says it wants everything greater than 4, so I'm going to shade everything on the outside. And again, when we want this, the overlapping sections, that's going to be everything in between, basically the ring in between the circles. That should be the overlapping section. If you're using a pencil, just make sure it's the darkest section and you can tell the difference. And that will be our answer. Now, as a quick review, the circle also uses the distance formula as well as the midpoint formula. So just as a reference, you have the distance formula here and the midpoint formula there. And it's just a matter of plugging in the values that we give you. Just as a reminder, when I give you coordinates, I always give you X and Y. And then just as a rule or something, if you kind of struggle with figuring out, well, which one's X1, which one's X2, I always like to think of it as if it's the first point that shows up, and for example, -1, 4 is the first point that showed up, then those are going to get the 1s. So not only is it going to be X1, it will also be Y1. And then for the second coordinate, 3, -2, again, that was the second coordinate that showed up, so I'm going to give those 2s. So now when I do the distance formula, I know exactly which piece to plug in each time. And so I need the X2, which in my case was 3, minus my X1, which is -1, plus my Y2, which is -2, minus my Y1, which was a +4. Pay close attention to negatives and positives on this, because the formula uses subtraction also. So that is a key detail to pay close attention to. That is going to give me the square root of 4 squared plus -6 squared. Just simplifying here. That's going to give me 16 plus 36. Simplifying a little bit further. It's going to give me a 52. And then remembering anything with the square root, we're going to take the time to break it down. 2 and 26, 2 and 13. Can't go any further, but I can pull out a group of 2's. One group of 2 with the 13 still remaining. And that is the distance between those 2 points. Again, that formula, the distance formula, we will need to have memorized for our test. And then there's the midpoint formula. Also needs to be memorized for the test. Okay, same rules apply. We can label each the x1, y1, x2, y2. Again, if it's the first one that shows up, let's call it x1, y1. And if it's the second coordinate that shows up, let's call it x2, y2. Using my formula now, I have parentheses, my x1, which was 1, plus my x2, which was -8, all over 2, followed by my y1, which was -6, plus my y2, which was -4. Using the formula, I'm just going to clean it up now. In the numerator, I get a -7 over 2, and then a -10 over 2. I have no preference as to how you leave your answers. I don't care if you leave it as a fraction or a decimal. But if that fraction is in fact reducible, that is in your best interest to actually reduce it. So I will accept either -7 over 2, -5. Or, if you don't like fractions, -3.5, -5. The decimal is probably the best option, just in case we were to have to graph any of these. Then it's easier to graph a decimal than it is to graph a fraction. But either or will be fine. So that is all for section 1.9 for circles. We'll go ahead and hop into ellipses in the next video. Again, what is important for circles is that both your h and your k are opposite because of that function. And your x and y's are both squared. They always have a coefficient of 1. They always use addition. And the number that they equal at the end is always your radius squared.